So in today's video, we're going to be doing the final part of the AP Physics 1 Unit 7 review on torque and rotation. So today, we're going to be talking about rotational energy and everything that comes with, the laws of energy with rotation. So as always, I will have my notes in the description. And yeah, so feel free to take a look at the other videos if you need to. And yeah, hopefully you guys enjoy. Make sure to leave a like if you do. All right, so let's talk about rotational kinetic energy. So rotational kinetic energy is just the energy an object has due to its rotational motion. And so the equation for that, so I'll call it K rotation, is going to equal 1/2 I W squared. So I, of course, is going to be mr squared, right? C mr squared. And then W is just going to be the angular velocity, right? Angular velocity. And so in a rolling object, there's both rotational energy and linear energy, okay? So with, I'll write K linear. That's just going to equal, we know, 1/2 mv squared. So the sum of kinetic energy in an object is going to be kr, I'll say, plus kl, which is going to equal 1/2 iw squared plus 1/2 mv squared. So a couple things. We know that energy is conserved unless there is friction, right? So we know that because of the work energy theorem, if there is work in a system, there's energy taken out, right? So in rotational kinematics, there is not going to be work because the friction is being acted at zero displacement. So what does that mean? So we know that work equals force times distance times cosine theta, right? And so in a rolling object, let's say we have this rolling object and it's rolling on the ground. Where's the friction at? The friction is going to be here, right? It's going to be, let's say the object is going this way, right? It's going to be here, this way. So I'll say F, force of friction, is going to go that way. So the issue here is that, sure, we have a force, but we have no distance from that point, right? So we have no force times distance. So while there is going to be friction, there is not going to be any energy being taken out of the system due to friction. So second of all, how do we know whether or not there's friction, right? So in these problems that we're going to be given, slipping, the word slipping means that there is no friction, which means that there's going to be no rotational kinetic energy, right? You're just going to be slipping. And so if we're told rolling or without slipping, that means that there is going to be force of friction, which means that we will have kinetic energy due to rotating. So some things to keep in mind is that V equals RW, F equals MA, and torque equals I alpha. This is going to help us solve a lot of these equations, and it's just going to make our lives way easier. So you'll see in a minute that knowing these is going to help us a lot. Okay, so let's take a look at this first question. We're given a bowling ball of mass m and radius r whose moment of inertia about its center is 2/5 mr squared, rolls without slipping along a level surface at speed v. The maximum vertical height to which it can roll if it ascends the incline is what? So we know that since we're not slipping, we're going to have that k is going to equal, let me write a summation, equals k rotation plus k linear. So what we can do is we can apply the law of conservation of energy to say that the initial energy is going to equal the final energy, right? So what we can say is that the sum of kinetic energy initial is going to equal the sum of potential energy final, right? Because at the start we don't have any we don't have any potential energy, and at the end we don't have any kinetic energy. So I'll write kr plus kl equals u. So let's substitute things in. So we're going to say 1/2 iw squared plus 1/2 mv squared equals mgh. So we see here that we have just v, right? We don't have a w here. So this is where it's important to know that v equals rw. So what we're going to write is v over r equals w. So this is going to be 1/2 times, I'll write 2/5 mr squared times v over r squared plus 1/2 mv squared equals mgh. So let's cancel some things out. So this m and this m and this m will all cancel, and then this r squared and this r squared will cancel, this 2 and this 2 will cancel, so we'll have 1/5 times v squared plus 1/2 v squared equals gh. And so this is going to equal 7/10 v squared equals gh. And so we're trying to find the height, right? So we can just divide a g here, and we'll say 7v squared over 10g is going to equal h. So our answer to this question is going to be D. Okay, so let's take a look at this next question. We're given an ice skater is spinning about a vertical axis with arms fully extended, and then we're asked if the arms are pulled in closer to the body, in which of the following ways are the angular momentum and kinetic energy of the skater affected. So we know that angular momentum L is going to always be conserved. We know that Li equals Lf. So no matter what, that's always going to be conserved. So we can say that A and B are obviously wrong, but now we need to talk about kinetic energy. So we can say that the angular kinetic energy, the rotational kinetic energy, is going to be 1/2 Iw squared, right? And so what we know is that since Lf, or just L, is going to equal Iw, right? That's going to remain the same, okay? And so Iw remains the same, so we can say Iw initial equals Iw final. So all we're looking at really, and this 1/2 will obviously be the same, so all we're looking at is the W increasing or decreasing. So what we can say to ourselves is that since Iw needs to be the same, when we lower our radius, right, so let's just say we have mr squared W, when we lower our radius, this is going to be less, right? So to maintain our angular momentum, the W has to increase. So here, our W has increased since we pulled our arm closer, so W increases, which means that the kinetic energy will increase, so our answer is going to be C. Okay, so let's take a look at these last two questions. For the first one, well, for both of these, we're given a sphere of mass m, radius r, and rotational inertia I is released from rest at the top of an inclined plane of height h. And then we're asked if the plane is frictionless, what is the speed, v cm, of the center of mass of the sphere at the bottom? So if it's frictionless, we have no kr, right? Which just means that kl, or I shouldn't write kl, kl will equal u, right? So we know that we can say this because everything is conserved, right? So we'll say 1/2 mv squared equals mgh. So these m's will cancel, and we're trying to find v. So we'll say v squared equals 2gh, and so we'll square root everything and say v equals root 2gh. So our answer is A. Now, question 3 is where it gets a little tricky. So we're asked if the plane has friction, which means that we will roll without slipping, what is the speed of the center of mass at the bottom of the incline? So now we can say that the sum of kinetic energy equals kr plus kl. So we can say that the sum of kf equals ui, right? So we'll say 1/2 Iw squared plus 1/2 mv squared is going to equal mgh. And we want to find VCM, so we want to get this W out of here, right? So we'll say V equals RW, so we'll divide both sides by R. We'll say that V over R equals W. So we're going to have 1/2 I times V over R squared plus 1/2 mv squared equals mgh. So 1/2 I v squared over r squared plus 1/2 mv squared equals mgh. And so now we can factor out a v squared here, right? So let me just go up here and we'll say v squared. Let's actually not go that far. We'll say v squared times 1/2 I or 1, let's say I over 2r squared plus 1/2 m equals mgh. So what we can do now is we can divide. So we'll say v squared equals mgh divided by 1, or I'll say I over 2r squared plus 1/2 m. So now we don't want our answer to look like this, right? So let's multiply both sides by 2, right, to get rid of that 1/2, so 2 over 2. And then let's also multiply by r squared, so r squared here too. So we'll have v squared equals mgh r squared, and there'll be a 2 in front, over I plus, and there should be a plus here, I plus m, right? So plus mr squared actually, because we're multiplying by an r squared. So now all we have to do is root both sides, and we're going to get that v equals the square root of 2mghr squared divided by I plus mr squared. So our answer is going to be D. So that's going to be it for the video, guys. Make sure to leave a like and subscribe if you're not already. And yeah, stay tuned for the next review. I'm not sure what it'll be. It might be calculus, SAT, physics. I'm not sure yet. But yeah, make sure to stay tuned, and I'll see you guys in the next one.